conferences. He served as a reviewer for various international journals. His dedication in guiding his PhD research scholars, PG and UG students is an evident in the unwavering commitment to nurturing the next generation of thinkers and leaders. He is an active DC member, PhD Viva examiner and doctorate thesis evaluator for many students in his career. His innovative ideas and in-depth understanding of the subject matter made him to receive the award of Innovative Project by young faculty members from Center of Technology Development and Transfer from Anna University. Also, his research paper received a Young Investigate and Best Paper Award in several international conferences. He successfully completed many funded research projects. Currently, he is working with the collaboration of National Institute of Ocean Technology and involved in remarkable funded projects. His innovation expanded not only in presenting his research work, also in organizing various events. He organized numerous workshops, FDPs, international conferences. He always engaged him in countless academic activity by providing countless guest lectures, chairperson in international conferences, jury in technical events conducted in the university. His contribution as a judge for hackathon event conducted in VIT is a recent one. Apart from the academic and research activity, he served as a deputy director for University Colleges of Anna University, Chennai, where his dynamic work include the purchase and finance related activities in merger section is a really commendable one. His administrative work include co-coordinator of TNNA Facilitation Center for the Tamil Nadu Engineering Admission from 2018. He is a university nominee, Board of Studies for several Anna Universities affiliated colleges and other universities. He is also a member in Purchase Committee, Departmental Disciplinary Committee, interview panel member for the selection of PhD scholars for Anna University. Beyond the classroom and research, Professor Dr. P. Prakash sir is a champion of the committee engagement. He is a pillar as a staff in charge for TED Club of MIT that introduce new technological advancement and spark curiosity in the student. He always give a more to education and health, social life. Being a fitness person, he frequently participated in countless marathons conducted throughout our country. Beyond that, he is an active volunteer in outreach program like creating awareness in blood donation. His involvement in volunteering during flood in Chennai was remarkable one. Sir has a great achievement in their field and has significantly contributed to the community and society. Their achievement and dedication to their work serve as an inspiration for all of us. So let's give a round of applause to welcome our expert. So now I request Dr. Rajeshwari Madam to give a token to our expert.
Faculty development program sponsored by ATAL. So, my topic is give an overview of feature extraction method. So I begin from here, from the intro word given by the madam. Is it okay? Yeah. What we, what you extracted from this intro word given by Nada. Can any one of your any few thing? It's a speech extraction. A very simple one. He said something like, he started like, I'm doing this, I'm doing that.
It is a test for the competitor now. How much people have extracted.
You are a
All-rounder
multidisciplinary
personality.
person.
All-rounder personality.
Good social intent.
Yeah, thank you.
Let's bring.
Exactly, thank you. So that is a very basic thing, right? In a common scenario, that's the basic thing we need extraction from all the aspects, right? From the day-to-day life, from your juice extracted, then whatever we have just gone through in our day-to-day activities, we are extracting everything, right? So the basic idea about your feature extraction is very fundamental for your image processing. Am I right? Yeah. So the interesting topic is computer vision for multidisciplinary research. Actually, the computer vision I think so we can start in the 90s. Am I right? Yeah, I think they started in 1970s, but in 1990s they have given more importance in this computer vision. Then in 2000 we got many algorithms to come up with new ideas for your computer vision actually. Okay, so I'll start with my first slide. It might be interactive one, so don't feel any hesitation to, you can stop me anywhere or you can ask anything, you can stop, right? Yes. Yeah. Is it visible to you?
Yes.
Is it readable?
Yes.
You can extract from this? Yes? So the full tours we are extracting everything, right? From this row, we are going to extract everything. Okay. So what statement is? Oh, sorry. What is this? Can anyone of you read about this and what do you understand from this? It's not my own actually. The famous book from your Gonzalez. Those who are doing image processing, everyone will have the book and they will keep it in hidden. They are sleeping with the book only. Very fundamental book in your image processing. Am I right? So what exactly it says? If you want, I just read it out. Well, but reflect. Having not several times acknowledged that names rightly given are the likeness and images of things which they name. They are given that for a definition for this in this famous book. What exactly it means here?
So it can be 1,000 words equals to 1 image.
Yes, exactly. Some other interpretation for this? No, you're just speaking freely. It is not a kind of thing. You just can talk. Whatever you know. One of the ma'am said exactly one. Other what other things we can interpret from this? Feature extraction. The famous quote is given that by the image itself we can give some thousand meaning for that kind of thing. Is it right? Okay, then you can easily understand this from the next slide. Feature extraction is the fundamental process in the operation of most automated image processing application. Right? Tell me what is this? Temple. How you extracted this? temple?
Structure.
Because we came across this when their parents and forefathers said the temple will be like this in structure. Am I right? Yeah, exactly. You know which temple is this one? The famous one, historical place in South India. I am basically from South India, that's why I am just giving more examples in South India. Don't worry, I mean, no mistake that I was just put on this. I want to explore the things to you only. When you visited there, definitely you go there. No, that's why. Nothing else. It's not a Balaji temple. The famous one, King Rajaraja Solan. How many of you visited Tanjore? Tanjore, the big temple, we call it the big temple, Tanjore. What is the speciality in it?
It's made up of one rock.
Yeah, this one is made up of one single rock, several tons of this one. Another interesting. Another interesting part in this temple in history says regarding the shadow they are talking about. Shadow? No shadow is there. Then these are the very unique feature of this one. What are other features you know about this? So regardless of it's the only thing. So as soon as we see this structure, you can expect this in a temple. Am I right? That's because we trained from your childhood that temple will be like this. Right? I'll give one more example here. The doll is shown there, no? Again, from the same part, we used to call as a dancing doll. In Tamil, they used to say Talayati Bommai. You have seen the structure of the doll? It's basically based on your center of gravity. Wherever position, you'll come back to the original one. There is a science behind that one. Can we relate this with that temple? The main part of the doll, feature of the doll is wherever you just keep it, again it will come back to the original position of that one based on the center of gravity. Right? The history says the doll made up of like this only, right? The base of the temple will show the same structure. That's why the doll become very famous here actually. That is the strength of that temple actually. It's coming. So what I want to say here is whenever you just see some image, automatically our brain says what are the features we can extract from it. Am I right? So the basic thing, first one is based on your known place or wherever you visited the temple, then automatically we realize there's a temple and there is a very famous doll. Another one is there is one more doll is there, we call it a dancing doll in Tanjore. Let me show it. Feature extraction.
Extracting important attributes.
Yeah, extracting important attributes for what?
Pattern recognition.
What type of pattern recognition? Okay. We can talk about very fundamental, very real time. Why we need feature extraction in real time. Not too much of technical funda. I'm just talking about very very recent, real time. What
So
Let's
that
see.
more than one, if more than one things are there of the same type, those could be compared or somehow those could be related.
Okay. So for that we need a feature extract. Okay. Can you tell me one application in your home? This kind of thing we are doing for feature extract. Just day to day. I'm asking about day to day life, not in your.
While eating food,
We can
think about the ingredients.
Exactly. That is the one thing.
Also for identifying fruit, like human vision also, internally we think about like, subconscious mind thinks about the features and accordingly we choose it 4-5.
Exactly. Yeah, even yesterday Rumi sir said that regarding the laddu, right?
Yeah.
The laddu, we said when we see the yellow color itself, we can say it's a laddu. Right? Regardless, it's maybe a Tirupati laddu or a Balaji temple or whatever maybe. Once we know the feature of that one, and we know the color of it one, that is the one actually. I just tell you that the dancing doll. Yeah. I think you've noticed this one, right? You've seen this. Yeah. This is for mainly for your color. Right. So madam said this is the one. How many of you know this? Again, the best example of your color feature extraction. I'm not tempting you guys for a breakfast. I'm just. Huh?
Rice?
Yeah, it's made up of rice only. We used to call this as a rice cake. Actually, in Tamil they used to call a kolkattai. Okay.
Modak sort of.
Okay.
Ma'am helping me. Thanks a lot.
Momos.
It's not momos actually. It's not momos actually. It's fully made up of the rice only. And when they added in the sugar content, it will become like this.
Without sugar, this is
Yeah, this is without sugar. It's in
South Indian.
yeah, snack item. Okay, what kind of snack you can. I am projecting all the South Indian dish to make you to tempt you guys to just taste it. Because whenever we come here, we are having all the things for like poha and vada pav. And just for 2-3 days, I'm just having the same vada pav, roti, poha, not even idli, dosa. Okay. So you guys come like this. Okay, that will be good for exchange of ideas. So see this. This is a thing. This is a color feature extraction actually. That is a thing. Both the thing made up of rice, but one of the things is a sweet one. This is number one. Again, yeah, Onam Thali. Yeah, exactly, Onam Thali. The idea behind this picture in a food wise, a balancing food diet food, regardless of your feature extraction. Organizing then
Different types of food.
differently in terms of your image processing, colors, textures. That is the idea behind this actually. And this is one very interesting one. You guys all know this, right? Again, it's a food called sweet pongal. Sweet pongal. Yeah. So again, the thing it's based on everything is only texture, color. This is one idea behind this. Other example, I just told you, the heritage. Wow. This is a base for everyone, right? Right. Nowadays, we just see you can go for a big era is going in digital agriculture. Recent days, we are just going with vertical farming, and we are doing many research in this. Many countries are very well in this. based on this agriculture. So here we can, in each picture we can form n number of problems here based on your extraction. Am I right? You just take this picture alone, this image alone, we can do n number of image processing. We can apply any tools or any algorithms to, we can, for one basic thing we can do is we can segregate which is the rose pun, which is the, what are the other flower, it's in yellow color? Yeah. Yeah, 70 leaves, you call it 70, so it's a marigold. Exactly. So there is an idea why we are going for feature extraction. So now I am coming to the intro of that one. So that's the basic definition what they are given. Feature extraction is an important step in image retrieval, right? And image processing, data mining, and computer vision. That is the funda of your FE. And it also the process of reducing the number of variables in a data set while retaining as much information as possible. Alright, when you see the temple picture, you just seen only the structure, you said it's a temple. No need to all the data what is there in the picture or there is an image. You just see only that structure of that one, you just immediately recognize as a temple. So that is the concept of your extraction, process of reducing the number of variables in a data set while retaining as much information as possible. Another one is it's a vital step in machine learning as it helps to reduce the complexity of the problem and improve the accuracy of the model. So that is the introduction of your feature extraction. So this is the basic blocks or entire setup. You just input image, you have pre-processing, segmentation, from this way just extracting feature extracted, then interpretation of that one, then given the output block. So feature extraction is a method used to extract features which may be depend on the geometric, statistical and textural as well as color features. So we will see one by one here. So each type, first we can start with this color feature. Is the color feature itself divided into color movement, color histogram and average of RGB. So what is this image shows here? Can anyone interpret from this? This is the input image with grid definition. What is this one? Yeah, we are rolling die, right? So what does this says? This from this, what do you understand from this region?
Portion of the
Yeah, portion of your die is there.
extract only the
Pixel.
Pixels.
background.
Exactly. What exactly it means here? So from this, we are just taking what this box indicates here.
Boundaries. Segmented.
Segmented boundary. You just come down. We are in this first part of your image processing.
Pixels.
No, I'm just talking about this.
Grids.
Grid. Other name for this? Grid. Huh?
Matrix. Cell.
Cell. See? No. My question is, from this image, how we are getting this?
Base.
We are just
Background. Scanning.
we are scanning through this grid. Okay, so from this part is only this one.
Filters.
Okay, filtering. Then what is this indicates what?
Position.
See, It's in two-dimensional, right? What about this?
One dimension.
One dimension.
One dimension.
So we are just extracting from this image this one part of the region which will have the two-dimensional one. Then we are from that we are going from a feature vector of this image to one-dimensional one. Okay.
What that represents, sir? 13.
The matrix for this vector actually.
Vector.
So what is 13?
So vector represents.
Vector representation of this two-dimensional image into one-dimensional one. For example, I have given this actually.
Yes, she is asking those values are representing intensities.
It's a conversion of vector.
Color value of that image.
Color value.
Yeah, the value of this image is represented here in a one-dimensional form. Just giving and exactly that value here. And just representing this two-dimensional into one-dimensional. The objective is when you take this part alone, you can represent this two-dimensional region. We are just taking this region alone that can be extracted in one-dimensional for feature application. Okay. So this is the main classification of your feature extraction technique. One is general features, another is domain specific. In general feature, you can go with your color, texture and shape of this one. In color, we have methods of color histogram, coherence vector, moments and parallelogram. And go with the texture, we have spatial and spectral, and shape we have region and contour. These are the types of feature extraction. One is you can go with the general features, and then your domain specific. Domain specific is a fingerprint, human face, conceptual features. And this is nothing but your photometric and geometric. Right? So let's just see one by one in detail. What does this indicate? What do you extract from this?
Features
So
of
filter.
Facebook.
You have to filter data.
We have to filter the data from these
Social media.
social media for your features, right? I'm just giving some. This one. We can start with your color features. So it's describe the color distribution and characteristics of an image. The example of your color features include color moment and color histogram and average of your RGB values. And this provide the insights into the color properties on an image. It's often used in your image retrieval and object recognition. Whenever we do with your retrieval and object recognition part, we can go with this color feature. So this is the best example of this color feature extraction method. So the right side we are indicating the labels of the different colors, right? In the image, you just see how much this level is present here, around 37.6, and this is in 13.1. This color is present in 12.8 and all. Why need this actually? Why this kind of color feature extraction method is there? What is the main need for this?
Exact color. We can.
Color percentage use that in the image.
Yeah, color percentage that is used in the image we know. Where we can apply this in your real time, this is day-to-day life. Can you tell me one example of this color feature extraction? Huh?
Object identification.
So object identification and all, okay, I'm just asking when you see the color itself, we can say the tomato is
Fresh red
yeah, or not, right? One is there, other? Such kind of application I'm asking, not that technically one. I just then we can relate it to technical. That is the main idea here actually. Because everything is what we are doing, we are relating into the technical, not technology comes from the I don't know. No. Everything. See, because when we see the tomato, if it is too, fully red color, then we can say it's a right one, right? When it is in a green, it's in a raw. If it is half green and red, it's a mixture of that one. So, for that, when we automate that one, we need this kind of extraction method to group that into write one, raw one. It will take another 2, 3, 4 days to write one. We can segregate that one. It will play a major role in your automated industry, right? So that can be, you can relate that when what are the applications you want, what are the problems you're going to solve, that you can relate with that one. This is the main idea behind this color feature extraction method. Yeah. Color features are a key role in applications like medical imaging, quality control and restoration part, art restoration. It also enhances our ability to interpret and manipulate visual data. So for example, this is the original data, red, green and blue channel. Why this? What is the significance of yours extracting in channels? What is the application point of view? Where we can see this, even our eye automatically recognizes red, blue, green, then you combine with another image, right? So similar kind of application you have, anything in your mind? Where we can, one image is given as of R channel, green channel and blue. When we talk about medical imaging, there we need a particular,
MRI.
yeah, exactly. MRI, when you just talk about your MRI, that one particular channel is going to diagnose if it is a good one or healthy one or unhealthy one, right? So such applications require this kind of color features. Other one, histogram, color histogram. It provides a compact and quantifiable representation of the distortion of the colors in an image. And it's valuable, image retrieval, content-based image search, and object recognition based on their color characteristics. What this indicates? You have done some exercise in that yesterday's class. It indicates what? This is an image. The color histogram of this image. The x-axis shows the pins of that image, and this is nothing but number of pixels in your y-axis. Right? This means what? We have done some coding yesterday, no? Just we have seen that when Ruby sir said when you this side your mark is 90 to 99, and when you go to the right hand side it will 35 to 45.
The range of contrast and
The range value for the
contrast and the brightness and the low brightness.
low
Less contrast,
high contrast. Okay. Then what indicates here? What is this value?
It's
It means
high contrast.
Object.
Number of pixels.
brightness.
yeah, the number of
High range.
pixels falls in this range, right?
Right.
From this image. Can you give me an example of this color histogram where we can apply this color histogram? Where we can apply this?
Attendance.
Yeah, attendance. So we can mark it as a
Stock market.
stock. Then, yeah, stock is the best example for your color histogram. See?
Percentage of this.
Percentage of
Market or yearly market values.
yearly market value, again we can just group it in those.
Weather forecast.
Weather forecast. So we know the significance of a histogram, why we need and where we can go for equalization part, everything in yesterday's class. So this is the thing in color features. One is color moments and the color histogram. Other one is your coherence vector. We can represent this in vector 1D form. So the informative way to represent the color content and the spatial distribution of colors in an image That is mainly used for your retrieval task. Wherever you want to retrieve the original image, you can go with this coherence vector.
Sir, for that image, why that histogram is on the right side?
This one.
What is the meaning of that?
Yeah, you already mentioned this one. There is a high intensity images placed in this range.
Means what?
Right side.
So 100 to 250 is spike.
No, I'm not pointing. I'm giving point here actually.
For this image, specific,
Ah.
with example,
Okay.
why that blue bar is on right side?
For that particular image, why that spike is there?
Within the range
It's a
200 to
color,
250.
right?
See,
intensity,
this is the
right side.
what do you mean by bins? You know?
Yeah.
You know the bins.
Yeah.
In that bin, which color is maximum?
Okay.
That is given here. So from this image, this color is maximum. That's why they fall in the items of that color. The demo is there in that actually in your class. We have this now.
Today
Yes,
is
yes. No, even we have. I just gave a demo on this. Okay. Once my class over, I'll just give this and I'll show how we are getting this one. What else? Image is there. The demo is given here. So the coherence vector and this is color moments. You know, moments are nothing but based on your statistical properties of that image. So there are statisticals, mean, standard deviation, and skewness. What is this mean, standard deviation, and skewness? Can you give any one of you? Mean is nothing but your average.
Standard deviation is nothing but to find out the errors.
To find out the error. Then
Last one,
skewness. What is skewness?
Right and left side integrate.
How data is distributed, whether it's left distributed or right
Right distributed. Alright, that is your skewness. Okay. So the moments statistical features used to describe the distribution of color in an image. So this will give the information about the color content, balance, and variation within the image. There is color variation within the image. So there is a mean, standard deviation, what other thing is given here. I'll tell you how to calculate this one also. Next one is your color parallelogram. What is this? We know correlation. What is parallelogram?
Positive, negative. Relationship positive.
Exactly. Relationship between
Two variables.
two variables. That is the thing.
Correlation.
Correlation. It quantifies the spatial correlation of colors at different distances within that image. Within that image, we are just counting the difference between these two. One. The main application of this is recognizing the textures and patterns in image based on color distribution. Here we can again, the main application of this one is again in medical image processing. These are the different color spaces. So RGB, HSB, HSL, U, Y, YCB, YCR, XYZ. So you just see this is the original image and hue channel. When you just go to hue channel, this is the one, and this is saturation one, value channel, again L, A, P. I think we have the demo for this. Yes? Okay. So this is the different type of colors pieces given here. Whatever we have talked about, everything is in your color features. So you just see this is the clothes and hair color and skin color. Join this, you get this. Where we can use this kind of application? Feature extraction of this is mainly for your
Particular part.
where we can use this? Exactly, in surveillance. So this is the main part of your surveillance. So this is mainly the color feature extraction. Yeah. So next one is your texture features. So texture features, statistical one. So the example of the statistical features.
Entropy is low means uncertainty is less. It means that particular feature contributes a lot towards the information.
Exactly.
And when entropy is more, it means uncertainty is more and it is.
Can you give me example of this in a real time?
Actually, sir, if any container contains a same color, means suppose the container has a red completely, so entropy is 0.
Zero.
And
Okay.
if it is having a 50-52 colors, that means it's a high 1.
One, entropy is one. Where we can use this? That's my question. Exactly what understanding is very clear. So, if it is both the 50-50%, then definitely your h of x will be 1. Whereas only 1, there is no uncertainty, obviously it is 0. But it's fully same color, again 0. Where we can use this kind of thing?
Regarding while selecting the features.
Okay, by selecting the features. No, I'm just talking about some application.
In mechanical application in pipeline or the measurement of liquid means
Okay,
H2SO4 and
that is one application in the mechanical part. Some other. Why I am talking about this? Whenever I talk about one or I talk about application in the sense, there is n number of problems in that every part of the image process.
Whether fruits are ripen or not ripen.
Yeah, exactly. That is the automation industry in fruit. They are doing this. They are just calculating all the image statistics. Based on that, they can easily segregate that one, which is the one good and which is the one not good and all. Right? So this is the main in whenever you just do your image processing problem. So you can see you just start as yesterday sir mentioned, you just take a photograph of your table. Below the table you get many number of problems. Alright. Like that you can do n number of research based on this every part of an image. We know this in medical field, the color image processing is playing a major role in this actually. What is RMS? Root means square value. How it will be for an image? Or it tells the characteristic of this one when it is RMS value is. We know that it should be very minimum. We accept it. Your RMS should be very minimum or error free, and we can say this. You just whenever you do this kind of analysis, you just see what will happen the value is maximum, what will happen the value is minimum. It will give a more idea about an image to do your further processing action. So this will give the insights into the texture and patterns present in an image, and it's often used in classification and diagnosis application, the domain of your texture. Features. I think this is a video. Busy? I think this is yeah. Small object recognition based on geometric features extraction. What are the images present there? Those who are familiar with the mechanical? Bolt, nut, spanner kind of thing, right? So this is an example for a geometric feature extraction. I think the audio is there, I think so. Again, one more example. Just play this now. Real-time geometry feature extraction and annotation.
So audio is there.
Its audio is there. It's not played actually, you just close it up. So this is augmented reality, AR. I think not cleared actually. I'll just
Without audio.
yeah, that will good actually.
No audio.
Can you please
audio,
replay that
no
without
audio.
audio? What do you understand from this? When you how the AR works here? When you scan through this, what is happening here? Yeah. By using the shapes what you are given in that application. Am I right? So we have sphere, cone, and circle. So this is the one rectangular one. So it's mapped with that. Annotated with the rectangular one. The next one is the next way we move through this again a rectangular. When you just move the next one, yeah. You just see this is the cylindrical one and two circular parts are there. You just see the image and you can see both the one the scanned one as with the original image is there. You just see that both one is in the circular, right? And that coffee cup is given in cone shape.
I welcome you all to the second session of the day. To deliver the session, we have with us Dr. Sasithara Devi from Vellore Institute of Technology. Dr. Sasithara Devi serves as an associate professor at the School of Electronics Engineering and Center for Advanced Data Science, Vellore Institute of Technology, Chennai. She completed her doctoral degree in the domain of computer vision and video processing from Anna University in 2018. Her commitment to education is evident through her mentorship in the TNSCSTA Student Project Scheme and her participation in doctoral symposiums. She has received several accolades, including a Certificate of Appreciation for guiding students in the Samsung Prism Worklet and Women Empowerment Award from the International American Council of Research and Development in 2018. In addition, her academic pursuits have taken her to international conferences supported by TNSCST Travel Grant Award for attending IEEE Flagship Conference 10Con in Malaysia in 2017. She has conducted various FTPs, workshops and hackathon events in computer vision domain. Her research experience had made her to collaborate with National Institute of Ocean Technology for underwater projects. Currently, she is actively involved in meeting funded project in the field of machine learning. She was appreciated for her dedication towards research publications for the year 2022, her contributions to academia, and her guidance to the next generation of researchers make her an invaluable asset to the academic community. I welcome you, ma'am. Now, I request FDP co-coordinator Dr. Deepa Abel to kindly felicitate Dr. Sasithara ma'am by presenting a memento.
I think I don't need mic. Am I audible?
Yes.
Okay. Thank you. Should I come? Connected. After the lunch, so it's pretty completely technical. We are just jumping from the overview, and after that, listening to so much of applications, we are just jumping directly into the technical one. This is going to be the first very much technically oriented session in this FDP, I think. So in today's session, you will learn about what is hog, what is SIT, and what is surf. And for what applications we are all going to use these. And I have done few variations in hog, and that was published, and through that only I got my doctoral degree. I am sharing that work here too, right? And I will be showing you few videos, and I will be throwing some research gaps on that. You can work and you can start your research. Shall we go? In morning session, during Prakash's lecture task, you understood what is color and what is texture. You know that we are having so many color spaces, and texture, what does texture mean? That refers to the smoothness and the roughness of any image. And another one important feature, that is geometric feature, that speaks about the shape or structure. The very first example that we have seen in the image, if you remember, it's the temple, right? And you know that the pyramidal structure is giving you the idea that it's the temple. Nowadays some research is also going that this pyramid is somewhat similar to Egyptian pyramid also. So we have this geometry is making us the entire thing in the world. You know the shape of the globe. What is the shape of the globe? Elliptical, right? So again, that is geometry. So geometry is another one important feature, that is that any computer vision application is having within it. So you just see this image. What is this? Mangoes, right? This is not the only one variety in mango. Can you name the variety of this mango? Alfonsa. Very good. This? What is this? Can you name the variety? Any idea? Even I also don't know. Actually, the that was the sweetest thing in MATLAB, okay? How we are differentiating it? Color is same, texture is same. How we are differentiating it? For example, if I want to do any surveillance related thing, I want to detect any pedestrian who is crossing the pathway. How we can check it? Based upon the structure of the human. Will be having head standing, but dog will also have head, legs and all, but it will be in the sleeping lane. Human will be having the torso as the camera, so that it should move without like falling down even in the staircase and all. So like that we have designed the algorithm. For that it should detect what is in front of it. For that application we need object recognition. So everything is coming under geometry. That's the thing that I want to insist here. So we are going to understand about three important terms: key point detection, object detection, object classification, and image classification. So the thing is hog, sift, and surf, right? So hog is for one kind of like object. We can understand for what it is used, whether it is for key point localization or object detection or object classification. It is a human labor. For that, this object detection is going to be very much important. And the next is autonomous driving, which will detect. Talking of hub, I will divide the entire image into grids of cells, and as I have explained to you earlier, we had Gx, Gy. Now we will compute that gradients. First, anyway, you have to convert that RGB into grayscale, and that grayscale image will be divided into grids. And for each grid, you will be having 4 cells. Like if I imagine this as a grid, I will be having it like this. So totally I will be having 1, 2, 3, 4 cells. Right? And we have to compute the gradients, magnitude as well as orientation. As I said to you, you have to remember that histogram for mapping the magnitude as well as the orientation. And we are not taking that 80% of the peak. We are going to use that histogram feature entirely as it is. We are not doing any kind of thresholding, or we are not choosing, or we are not selecting the features from that. So at the end, you will concatenate all the features. For example, you can see here. So for this dog, you have chosen only the left eye. I have chosen only the left eye. So if I have this patch and I am taking 1 pixel, you know how to calculate Gx and Gy. Gx is difference between these two, and Gy is difference between these two. And you have to compute the gradient as well as the gradient magnitude as well as gradient orientation. So here, normalization is done with the histogram, but with SIFT it was not there. So it is not illumination in varying. Doing normalization will avoid the illumination variancy. You can see here. So anyway, you have to resize the image. Common size you have to keep for all the images. You have to resize the image. It is we can resize the image, and after that you have to normalize it and convert that into grayscale. Calculate the image gradients. So before performing, like what do you mean by gradients? Yesterday you done for Sobel operator, Privet operator, na? What was that? MATLAB coding was given to you. You run it? Yes, right? So that you can detect the edges. Edges are nothing but gradients. So you can create the gradient using edge detection filters alone. Filters also, and you have to compute the gradient magnitude and direction, and divide the image into small cells and accumulate the histogram that is obtained from each cells. Concatenate that, so that you will arrive at the histogram. After that, you have to normalize the histogram. What do you mean normalization? Take out the maximum value and divide the entire things by the max value. So you have that. Apart from that, they have used L1 or L2 normalization, and at the end you have to form the final feature vector. So that will describe the edge feature for the image. So first, I am resizing the image 1 into 128 cross 64. So the image has become somewhat smaller, and we have to find the gradient. So if this is going to be the gradient image for this gradient image, and we have to compute the gradient matrices, that is the magnitude as well as the angle matrix. For each block, as I said to you now, each block will have 4 cells, and each block will be dividing the histogram into 9 wings. So you will be having 4 cross 9, right? So totally you will have 128 cross 4 cross 9 histograms. For example, so for your clarification, they have used 50% of overlap for the windowing. You know that it is. Actually, I had one mask in. It's not visible. So you will get one 9-point histogram. So for example, if they first you just see here, if they were using these 4 cross 4 blocks. So first they will compute this 4 cross 4 blocks, and after that 50% overlap. That means they will start from here and next to 4 cross 4. Again 50% overlap. Start from here and next 4 cross 4. Based on experimentation, they have decided that partial overlap is providing good results when compared to non-overlapping windows. So for each 4 cross 4 window, we will be getting the histogram, and at the end we will be concatenating all these things, and we will get the final feature vector for the image. So here you can see the calculation. So 4 blocks from 9-point histogram are clubbed together to form a new block, and it is done in an overlapping manner, that is partial overlap or 50% overlap. So the total length of the hog will be 7 multiplied by 15 multiplied by 36. So 36 you got from 4 cross 9. So this is the number of blocks that we will get from that 128 cross 64 image. Got it? So the entire for the entire image, so for 128 cross 64, we got the feature as size 1 cross 3780. Such a reduction, but efficient. These were some of the variants in hog: rotation invariant hog, weighted hog, pyramidal hog, soft hog, HOMG, HOGD, and spatio-temporal hog. So based on this spatio-temporal hog only, I have done one variation in this hog. So that we will look it now. This application seriously. Yeah. So this is pyramidal hog. So for this entire, so this is the real image, just divided, that is, it is partitioned into 3 types. Like we will derive the 3 images from the original image. So for the entire thing, we will find the hog, and for this patch hog, this patch hog, this patch hog, this simply will divide it into 4 cells and concatenate it again. And after that, again I am splitting it into 2. Pyramid I am creating. The whole pyramid, second level, third level pyramidal structure. And all these things are added together to provide the pyramidal hog. So this hog is this P hog performs better than the real hog. In this they have overcome that scale fix. Scale invariance is introduced by this pyramidal structure. So here you can see the operation. The original image is downsampled at multiple scales. So that we have arrived this scale invariance. And at each level the pyramid represents different resolutions. Gradients are calculated as hog, and the hog at each pyramidal levels are concatenated to combine to get the combined histogram. And at different scales you will be concatenating that. So that is providing both the local information as well as the global information. And you know that if we get the local information, it's going to be scale invariant. So the applications are object recognition, classification, and scene understanding. So it's robust. As it has both local and global information, it's scale invariant. It follows pyramidal structure, and the histogram construction is based on concatenation. It's based on gradient computation also. I think we can have 5 minutes break, and later we can start. Actions that is available in the video. Day-to-day life things they have introduced histogram of radon projections in one conference, and in another conference I listened about spatio-temporal hog. You can see here, ST hog. You see, ST hog is there. And I listened about histogram of radon projections, and those two idea I used it. So that is the benefit of attending any good conferences, and you can also follow that. So in this work, we introduced a scale, rotation, translation and illumination invariant spatio-temporal histogram of radon projections, so which work far better than spatio-temporal hog. And I used this, I reduced the dimension of STHRP using LDA. I think morning Sat had discussed about LDA, linear discriminant analysis, and after that classified the objects. And at the end I have done retrieval. I said to you now we will be having one gallery. We have to pass the query as image or text or video. It should retrieve you the relevant things. So at the end I have retrieved the image based on the video. And what we have decided is, it's reduced, that is before retrieving the image, if I classifying the query, it's going to reduce the much of computational time. And we have evaluated the performance of STHRP and compared with the recent state of the art methods. This is the idea. So we will be having so many videos. I have computed, say, spatio-temporal histogram of radon projection for all the videos, and it is trained and the knowledge base is saved. So this will happen in the offline module or the training module. So in the online module, user will raise the query. So, the input that I decided is video only. I am not going with any image or text. And again, STHRP will be computed, and after that, it will classify which class it is. Using the predicted classes from the gallery, the video will be displayed to the user. So you just imagine of the bread. So bread, just without cutting, you just imagine the whole bread itself. So that is the structure of the video. And I have sliced the bread like this, and from top to bottom. XY, YT and XT planes. These three planes I have included here, and for each plane I computed the histogram of radon projections. So instead of directly plotting the gradient orientation histogram, I have gone for radon projections. So radon projections will count the number of edge pixels available in the image. So if the edge is varying, that will indirectly specifies the movement of the object. So if the edge is varying, in which direction? So edge is computed by radon projection, direction is computed by this hog. I merged those two complementary features, provided the good results. At each plane, I extracted the HRP, and I concatenated all these to form the spatio-temporal histogram of radon projections. Now you can understand, STHRP is a spatio-temporal feature descriptor that it captures both the appearance and the temporal function. So appearance is captured by XY plane, temporal feature is captured by YT and XT plane. So this will encode the meaningful pattern, that is scale, illumination, rotation and translation invariant, and it can represent a video, that is it is representing the geometrical information that is available in the video, and it captures both the appearance and the motion patterns. And this STHRP, like while I was submitting this work, deep learning was the king. It's also the king now, and deep learning is the king. So one query was raised by the reviewer that how can you say that it's competing with the recent deep learning methodologies? That it's requiring very less training data. That the problem that I taken now, it's having very less training data. Deep learning will require more training data, and with less computational power I can do this. At that time the GPU was of huge cost. Due to low resource power as well as due to low memory and all, we used this machine learning algorithm. Like that it is reputed. And this feature is invariant to translation, rotation and illumination variation. Because the radon projection is invariant to translation, but hog is not invariant to translation. Hog is rotation invariant and illumination invariant. So both the features provided the advantage of STHRP. Right, so input video sequence, we'll take the input video sequence, we'll find the radon projections. You can see here, this is the input video sequence. So this image is taken from, this frames were taken from KTH dataset that is having 4 actions, running, jogging and all. And this is divided into 3 planes, XT plane, YT plane and XY plane. So these 3 planes. So after partitioning it into 3 planes, edge detection is done using CANI operator. And after doing the CANI operator, we computed the histogram of radon projections for each plane. Right? So we will be having so many frames for one plane and accumulated all the histogram from each frames, and we concatenated the three plane histograms to form the spatiotemporal histogram of radon projections. Right? So this is just the count value. There is nothing wrong to add these values, just the counts, and normalize that to avoid the illumination variations. This is the comparison between STHRP and STCOE. So here it's based on radon projections, it is based on the gradient features, and temporal representation is also radon projections, here also temporal gradient features. It's robust to intra-class variability. So here it's combining spatial and temporal information. It is geometrically informative, and it is effective for video classification and retrieval. It is very efficient to compute. So weakness, it requires more training data than spatio-temporal hogs. That was the one weakness that we identified in STHRP. So we compared it with, so initially while I was submitting, now I don't know that these datasets were existing. These datasets were existing in this world, I don't know. I have done the result only for this TRECP 2007. Based on the reviewers' comment only, we came to know that these datasets were existing, and it took some 2 months for us to work on it, on these datasets, and we, fortunately we have got good results when compared to all of them.
UCF is from UCL or this is different.
Different.
University's data.
No. Different on activities, human action based data set. HMDB is actually action based on the video clippings that is obtained from movies, from Bollywood movies, and then context is one egocentric video. So one reviewer asked us to evaluate the algorithm on egocentric video. So we evaluated it on 4 data sets, and surprisingly all provided good results.
Are these datasets freely available?
Yeah, publicly available. Publicly available. So actually this UCF 101 is upgraded now. 101 is number of classes, that is number of activities, 101 activities. So here 51 activities are there, like clapping hands, running, walking and all different activities. So next is, this is also one, another one work. So it is, it's also published by Elsevier. A new pyramidal opponent color shape model based video short boundary detection. So that is this would be the new term, video short boundary detection. So this is one of the primary step in any video processing algorithm. Like for example, if in any movie you will be having so many scene variations. So that scene changes you will call it as shots. The take, right? So one take is one shot. So here different types of shots are there. Abrupt transitions, dissolve transition, fade in and fade out. You can just see that it is abrupt, right? From one scene to another scene it's abrupt. Here you can see it's just gradually varying. The scene is varying very much gradually. This is fade in, that is like daytime and nighttime is arriving now. So fade in and fade out transitions. And here it is white, like in the previous movies, so shifting from one scene to another scene. The clock will rotate, like with some music at the background. So we are having different types. The main idea is without processing all the frames in the entire video, if I take out one representative frame for one shot, it's that is going to reduce the computational complexity of the entire algorithm. That is the main idea. And the high challenge here is which is the representative frame and where the shot is there. So that is identified through pyramidal opponent color shape model. So here you can see the hybrid version of the color feature discussed by Prakash and the shape feature discussed by me now. Here you can see. So first, see here. First is we took the frame and converted it into operand color space O1, O2 and O3. So one mathematical formula was there. So using that we converted. The main advantage is that it will reflect the human visual system. So these were the three individual color spaces O1, O2 and O3 frame. So I computed gradient. So this O2, O1 is representing the grayscale image. Simply the grayscale image. So this is following the Hogg computation. Simply Hogg computation. That is the shape. Shapes, yes. So this is operand color space. I am taking these two frames to form the already actually one will be the gradient one and assuming one has gradient and another one has the orient. This combinedly created a one histogram and I concatenated these two histograms to form the POCS model, POCS model. So it's combining both the color information and this shape information. It's possible for us to hybrid the things. And nowadays you can also provide both traditional features and neat features. You can combine those two also to get good results. So I have extracted this feature, this POCS feature for all the frames that is available in the video, and I computed the absolute difference between these two features. So for all the frames in the video, I computed the POCS feature and find the difference between the things and plotted, and I call that signal as temporal continuity signal. If the continuity breaks, I can say that the shot is ending at that time or any transition is there. So you can see here. So this is one example. The NT represents no transition, AT represents abrupt transition. So this is the difference that I said to you now. POCS I have extracted now. So if there is abrupt change, you just see this image. So there is abrupt change, right? So this is the plot for this V2. This is the plot for this video. No transition. At this point there is no transition. If there is peak, I can say it is abrupt transition. And you have seen that we are having four other different types as this also. All these types is called as gradual transitions. So detecting abrupt transition is somewhat easier when compared to gradual transitions because detecting the peak is very easy instead of detecting the gradual variations in the graph. You can see here this is gradual variation. So by referring all the frames, so this is resulting in somewhat Gaussian shape function. So I will be running the window overlapping mask throughout this and will check like at the center and the back. I will check some, will do some mathematical operations, and initially I will select the suitable segment using thresholding techniques. So here you can see I can discard the values less than 0.2, right, or 0.1. I can discard the values. I can take only the representative values and will train the algorithm. And the machine learning model I used here is bag trees model. Here you go. So we have the training module and the testing module. Videos are decomposed into frames and POC model is extracted. Disciplinary computation is the difference, and computed the temporal, that is using suitable segment selection. We have trained this bag trees model and we have classified it into three types: no transition, abrupt transition and gradual transition. Right? And now you can ask me what is pyramidal. You know what is opponent, color space and what is shape. What is pyramidal? You know what pyramidal Hogg, right? You have seen about pyramidal Hogg. Just few slides before. No, I don't want to go back. So similar to that, I have done here for the complete image, this pyramidal level 1, for the next pyramidal level, and for the third pyramidal level. So all these things, that is opponent, color, shape is done for all the three pyramids, and the features are concatenated. And it's very much efficient to detect the shots. So these were the HD is hot transition or abrupt transition. So this video is a TrekBit video. So the TrekBit community is conducting one challenge yearly for detecting the short boundary, and they are releasing the data publicly. And my algorithm overcome all the challenge results that was already available. So initial days they were releasing some NASA videos and all. These were the abrupt boundaries where my algorithm is detecting perfectly, where all other algorithms are failing to detect. So one variant is STHRP and another one variant is box model, and the third variant is histogram of Fourier coefficients. Right. So here, so this work was presented in one flagship conference in Malaysia, and we presented a framework for object-based video retrieval based on the feature that is called the histogram of Fourier coefficients. So here we are combining the shape feature as well as the transform-based features. We have seen transform-based filtering now. So here we are using the advantage of Fourier transform as well as the shape feature, and we have trained these features using some machine learning models and retrieved the objects. Like for example, so the thing is so here you can see that so first we will select the key object plane. So this key object plane is selected by extracting the salient objects that is present in the image. So here we have 5 different objects in the video. So in the for that video I have identified the shots using the short boundary detection algorithm that I have proposed earlier, and we have taken the representative frame out of that short boundary, and for each frame I have run this saliency algorithm, visual saliency. You can see this salient object detection. So this is based on one methodology that was proposed by the researcher. I forgot the name of the researcher, and this is visual saliency. You can see so many words, and this was the one that was working better for my algorithm, so I took that. So I have taken the video, converted it into frames, and extracted the key frame, that is the representative frame, using the short boundary detection algorithm, and detected the salient object, and I have put the bounding box around that object, and I will call that as key object plane. So for that object, I took Fourier transform. Fourier transform will result in phase coefficients and magnitude. Instead of magnitude and orientation, I am going to use the phase of the Fourier transform. Instead of gradient, I just used Fourier transform. And again the same weighted vote of the magnitude as well as the phase is done, and at the end I concatenated that to form the HFC descriptor. Interestingly, this HFC descriptor was distinct for all the 5 objects that is present in the video. So that was the video released by TrekBit in 2001, and I concatenated all the histograms of this key object plane from the grids to form HFC descriptor. So it goes around the same mathematics that was there in Hog. So the feature descriptor length is going to be same as Hog only. Instead of the gradient, I just changed the gradient as Fourier transform. That's it. So this is the precision recall curve for evaluating my algorithm. Like precision recall, F1 score, right? Accuracy, so all these things are the evaluation metrics. Here you can see how Hog is utilized to detect the person. So even though it's pose invariant, even though the person is in different pose, Hog can go ahead. You can visualize the Hog features. For example, in the previous image, they are detecting the human. So if the edges, so here you can see the edges here, right? So this Hog features orientation will be same for this. Here we are having some horizontal grids, so the orientation will be in 0 degree. So here you can see some slightly variations in the orientation. Based on that, it is detecting the human person. The orientation variation you can see in this one. You can see the orientation variations. Right? Do you have any queries in hog or any other variations? Shall we go ahead with steps? Speed up robust features. So it's a fast and robust algorithm when compared to SIFT. So it's invariant to, actually it's not invariant to scale, but it's invariant to rotation when compared to SIFT. So later some variations are done to make it invariant to scale, and it's the speed up version of SIFT, and the number of key points are lesser when compared to SIFT. So there you can have more key points. So here you can have either 64 or 128 key points only. And it is used for applications like computer vision tasks as object detection, image matching and image classification. So these are different steps in SURF algorithm. So as we have done in SIFT, we won't have any scale spaces here. So it is not scale invariant. And initially you will detect the interest point, and the interest point will be described, and it will be matched. But it's working better than SIFT. So you can identify the matching point between two images of different orientations of different geometries using this SIFT. These are the steps. We will take the input image, interest point will be detected. We will construct the local descriptor around the interest points. That's it. You will discard all other pixels that is available in the image. We will find which is the important pixel and will extract the feature around the interest point alone. And you can match those points with the testing image to get the result. So for interest point detection, we will be using Hessian matrix. The underlying thing here is integral image. So how will we construct the integral image? So if my 2 cross 2 matrix is 1, 5, 2, 4, I will maintain this 1 here, 1 plus 5, 6, 2 plus 1, 3, and add all together and put it as 12. So this is going to be the integral image. And Hessian matrix will use this kind of operation, and it will create the integral image. Instead of creating the different scale spaces, here SURF will use integral images, and after that you will detect the interest points for the given image. So this is the Hessian, so it's nothing but the second order derivative operator. So here you can find the differentiation over x direction, x and y, y and x and y direction alone. And after detecting the interest points, you will follow the same procedure that you have done in a SIFT, finding the local extrema of minima and maxima to find out the key points. Okay. So here we are not. Here we will be using this Gaussian kernel, two-dimensional Gaussian kernel, and will apply that on the Hessian matrix. So here we will be using box filters. Okay. We will be using box filters, and we will use the integral images and will scale up the filter. We are not scaling down, we are doing scale up. Right? We are not subsampling, will be upsampling. But anyway, there is not that much scale invariant when compared to SIFT. These were the, as I said to you, will be getting 64 dimensional, or else you can also get 128 dimensional feature vector. So next we will align the feature, that is orientation feature or square region alignment is done. Orientation alignment is done using Haar wavelet. So here Haar wavelet is used, and there we have used Taylor expansion as well as Hessian matrix. And this is the Haar wavelet function that you know. So square region is constructed by splitting the image into regular grid spaces. So this is one example for the key point. This is that is falling on the same like more orientation now. So you choose that key orientation use that as the surf feature. So here you can see so many changes, right? So here it's completely, there is no variation, so it's too low. Here we are having one-to-one variations, and here it is varying very gradually. According to that, we are getting the variations in the square region alignment. This is interest point matching. So even though the pictures are similar, the pictures are different, like it's somewhat higher, but even though both are same, but it is in a viewpoint variation. Issue is there. The correspondence point is matched between the two images.
So one image is stored in the database. One is
What?
in database already one image is there, and second image for testing.
Yes. So these were the variants of SURF, SURF 3D, SURF PF, SURF G, extended SURF, SURF IC, integrity, and multi-SURF variants of later. To avoid some challenges, like for different applications we are using, they may require some other solutions for their problem. To eradicate that, several variants were introduced. So these were some open research problems that you can work on. You can work on the Hessian threshold and number of neighborhoods that we are considering, that and all you can work on. But anyways, so many deep learning algorithms are available now. Some application areas similar to what we have discussed earlier. The comparison between the three features. The hog is fast, faster, and SIP is slow. So you can say that we are having only 64 features, right? And robustness to noise is very good for SIP. Robustness to geometrical transformation is very good for SIP. And distinctiveness is very good for SIP, and the computational cost is also high. So the takeaway here is, if you are designing any algorithm, that you should maintain a trade-off between the computational complexity and accuracy. But even though it is very good in the three aspects, its computational cost is very high. So as a final thing, I can say that Hog is somewhat better when compared to SIFT and SURF. Demo here. So this was the training image. It's matching with the testing image. Key points are edited and it is matched. So he is tilting, right? Rotation invariant, viewpoint invariant. This is achieved in SURF. So many codes are already available in the, you can start. Inbuilt function is available in MATLAB as well as in Python. One line within one line. My entire research work was based on classification, so most of the applications that I have shared now will be based on classification alone. You can use for all the detection also. This is real-time tracking. The person is using one web camera for detecting the objects and tracking. For example, if you want to develop any product, you can't go for any deep learning algorithm. For that, you need some edge ML. For that, you can use these kind of features. So, like after that, after getting idea, you can go for some lightweight deep learning models, and you can embed that in some Raspberry Pi or anything else, JSON and all, to create a code. So here you can see the hybrid between SIFT and SURF. So till now we have seen processing is done, and orientation, both the things, both the features are calculated, and both the features will be concatenated and stored it in the knowledge base, and again the finger vein is recognized. So this is the finger vein sub features, finger vein SIP features. So as a whole, how machine vision works, and I'm just summarizing what you have learned till now, how it's going to work. You know, we'll be having the first step as, what is the first step in any problem? What is the first step in any show?
Identify the problem.
After identifying the problem. Identifying the problem is the first step.
Data set.
Data set collection. Just go through this video. A simple one that whatever the things that we have studied now. Voiceover was there. You can see this demo in today's demo session. Just see this video. So, in research methodology, first, as you said, you have to identify the problem. To identify the problem, you need to do desk work. You have to discuss with your like-minded people, with your colleagues, with your well-wishers, and you identify the problem. And you do the perfect literature review. All these components are very much important for your work. You do the perfect literature work and find the research gaps that is available in that area and define your problem. And the very important step is data collection. Try to produce the solution for that. Initially you won't get the right solution. Rework, compare with the existing one, and at the end you will find the result. So this is the thing that you have to follow for any research. And one of the most important thing is you have to form the best team with your like-minded people. So the collaboration will take you to any heights, right? So best team is the must one. So find like-minded people, start your work, and I think I have thrown some light on few things. If your knowledge is somewhat X, at least it should be 15% of increase. It's X plus 15%. Right? You can connect me in LinkedIn, or you can connect me through mail, or you can follow me in research team. Okay? Our entire team is very much open to collaborate with any one of you. Don't hesitate. You can connect with us through any means. You can provide your valuable feedback. Thank you for your patience even after the lunch.
One doubt.
Yes.
How to create that orientation map?
Orientation map. Angle will be angle, and magnitude you will have, right?
You grades
360 degree you will be having that angle.
Yes.
0 to 360
angle values
degree.
are there and grades values are there.
Mm.
And I wanted to have that angle, that orientation in each and every cell.
Mm.
That is orientation map. So how to create in
That's what
the
I'm saying.
program?
360 in the program, if you put one liner, it will come.
It is there.
It's
Okay.
there. If you want it as a black box, you can use just that one line.
Okay.
Do you want to know the mathematical background behind that? I will explain. I think you don't want. Your face is like that.
That return function is there to get
Yeah,
orientation.
one line.
That return function